And welcome to Unit 9, Notes 3, Simplifying Rational Expressions. Learning target, I can simplify rational expressions and find excluded values of rational expressions. This is very good skills to have moving forward, is recognizing things that reduce and simplify. So a rational expression is an algebraic fraction whose numerator and denominator are polynomials, meaning they have x's in them. Meaning it's not just a fraction, they have expressions on top and bottom. How can values of x make the equation undefined? So this is any value that makes the denominator of the rational expression 0 is excluded. So there are values that make the denominator 0, which means you're dividing by 0, which makes the expression undefined. So what I just underlined in blue is the most common points off on quizzes. You need to make sure you understand when that is 0. So how do we find those excluded values? This is going to be, if the denominator is a quadratic, factor and use the zero product property. Meaning, factor, find two values or two expressions and set them equal to 0. And if it's just a monomial, meaning it's just a variable, set each variable equal to 0. So let's have a look-see. State the values that make each rational expression undefined. Alright, so I look at this. If m equals 0, 0 minus 6 is negative 6. So that's not a value that we're dividing by 6. So m can equal 0. So what you want to do is you want to take this and you want to set that equal to 0. Because m minus 6 equals 0, you add 6, m cannot equal 6 is what you're going to want to write on your quiz. So if we do a little math, get rid of this. Hey, if m is 6, 6 minus 6 is equal to 0. And this is when we run into trouble. So this is the exact correct answer. Now, when we go to number 2, this is a 1. If I guess and check, this is a 6. 1 times 6 is 6. This is a negative 5. So I would need, actually this is going to be negative, negative. I got negative 2, negative 3. So what I would do there is I'd probably rewrite the problem. X squared minus 5 equals x minus 2, x minus 3. Then what I would do, personally, is I'd write x minus 2 equals 0. You add 2, x thing we don't want to be 2. And then we also have the x minus 3 to worry about. So there's going to be 2 whenever you have to. You're going to add 3. X cannot be 3. There's going to be 2 values here whenever it is a quadratic. I just underlined the quadratic there. It's x squared minus 5x plus 6. So there's going to be 2 values in that scenario every time you see that quadratic. Now, when we get to 3, notice 3x is by itself. So when you are worried about 3, x can just not equal 0. Because 3 times 0 would have been 0, and now we have that division of 0 again. So this one is pretty self-explanatory. This is just x cannot equal 0. When we look at number 4, now we have 2 variables. Well, x cannot equal 0 like the last one. Or, hypothetically, maybe x is 2, but maybe y is 0 to the 5th. Well, 0 to the 5th is 0 times 4 times 4. You have 16 times 0. Either way, if y is 0, then it makes it 0 as well. So what I'm trying to tell you is you have to include both of them, and you write x cannot equal 0, y cannot equal 0 to get all the points on your upcoming quiz. In all the scenarios that we just did, if it equals 0, then we have problems. So simplifying rational expressions. So the other part of it is it's not all going to be just set out there for you to be able to do. You have to know how to simplify them. So looking at this one, we're going back to some awesome algebra that we just did. So right here, we have y's. Now if I look at that, 2 minus 7 is negative 5. Or we can know that that 5 needs to be on the bottom. With the x's, it's 5 minus the 1. So it's going to be 4 x's on top. And then 32 divided by 4 is actually 8. So this is how I simplify it. Those were our power rules. Now, when I get to that, if I erase the x, red and black there, we see there was an x on the bottom and a y on the bottom. And we don't want either of those to be equal to 0. So you have to be able to simplify this. So they were both on the bottom at one point, so you want to make sure you cross off both of them. When I look at 16 divided by 8 here, that's 2, right? I can look at b to the 4th, and b, 4 minus 1 is b to the 3rd. And looking at those c's, I know I'm in trouble because 2 minus 3 is negative 1. What that really means is I have one more c on the bottom. Now, c was spent some time on the bottom, and b spent some time on the bottom. So I like to include both c and b as possible issues. So I include both of them when I say that they cannot be, those expressions are undefined. Now, to make things a little bit harder, we got some math to do here. So with the x squared minus 7x plus 10, we said, hey, you're going to have to do some x method for us. So 10 and negative 7, I'm going to get two negatives because I know it's got to be a positive 10. So negative 5 and negative 2. Now, I would take this and I'd replace this with x minus 5, x minus 2. And that would take care of the denominator. Now, on the numerator, we have this interesting thing going on where both of them are actually divisible by 3. So this is the one that's most commonly missed on quizzes because kids forget to check this. So what I would do is I'd write a 3 out front because that's a GCF. 3 divided by 3 would be 1. So 1x, I got a minus sign. And 15 divided by 3 is 5. So you divide both those by 3. Now what that does for us is it allows us to get rid of these two values here. All right? These are going to cancel. Kind of like our probability stuff. It's the same thing on top, then it's the same thing on the bottom. So we're going to actually have this equal to 3 over x minus 2. So this is pretty common for us to do. Hey, let's make sure they know x method and then see if anything cancels. Now in doing this, 3 over x minus 2, I still need to include x cannot equal 2 because x minus 2 equals 0 here. You add 2 and add 2. Alright, now the other part would be the x minus 5. I'm still making you include the x minus 5. Even though it cancels, you're going to include it for me, so x cannot equal 5. Moving on to the next one. Alright, so now I have x method on top and bottom. So I'm going to go like this. I'm going to say, alright, let's go over here. This is this one. Negative 2 is in the bottom middle. Negative 35 on top. Negative 5, I'm wrong. One of them has to be positive. It's going to be the 5, and it's going to be negative 7. Because 5 minus 7 is negative 2. So I'm going to rewrite that as x plus 5, x minus 7. Now then when I do the bottom, right, I look at this, I see negative 9 on the bottom, positive 14 on top. I'm going to go negative, negative, and I'm going to go negative 7, negative 2. That would be a positive when you multiply, and then a negative 9. So I'm going to rewrite that as x minus 7 and x minus 2. Now one thing to note here is the only reason I can do that in both of these is right here, this red line. Both of those a values were 1. So make sure you know that this is why I get to just rewrite it with these values and not have to do the long grouping method. Now looking at that, this x minus 7 on bottom is going to cancel with the x minus 7 on top. Your final answer here is going to be x plus 5 And I'm going to drop the parentheses, actually. I'm just going to write x plus 5, x minus 2, and then maybe like a semicolon here. X cannot equal. On the bottom was an x minus 7, which equaled 0, so you'd have to add the 7, because 7 minus 7 would be 0, so x cannot equal 7, and x cannot equal 2, because x minus 2, you'd add the 2 to both sides, so you would end up with this. Awesome. So now a few word problems. Jenna has guppies in her aquarium. 1 week later, she adds 4 neon fish. Define a variable for neon fish and guppies, and write an expression that represents the fraction of neon fish. So she has guppies. I don't know what we're doing on this problem. So I'm going to go x for guppies. Later she adds y. I'm lame. I use x and y. Define a variable for neon fish and guppies. So I'd say an x and y. Then write an expression that represents the fraction of neon fish in the aquarium. So what I would say is the number of neon fish in the aquarium is y. Plus 4. However, how many fish are there in the aquarium? I don't know. We got to add x plus y together, huh? That would give us the total number, x plus y and x. I don't know. Suppose that 2 months later the guppy population doubles. Jenna still has 4 neon. Oh, she didn't have any neon at all to begin with. Oh, well then that's interesting. Let's go y, and then x plus 4. Actually, we know that y equals 4. So let's just do 4 over x plus 4. So this is actually how many fish are the fraction of fish that are in the aquarium. Figured it out. Suppose that 2 months later the guppy population doubles. Jenna still has 4 neons, and she buys 5 different tropical fish. Write an expression that shows the fraction of neons in the aquarium after the other fish have been added. So this is a pretty good word problem. 2 months later, the guppy population doubles. So what doubles? All right, it is actually just the guppies, which is our x. So what I probably would have done is I probably would have came down here and wrote 4, and I would have said 2x. Now before, we were just adding the 4 neons. But now we got to add 5 different tropical fish. Write an expression that shows the fractions of neon in the aquarium after the other fish have been added. So I would have said 4 plus 5 is 9. So this is the new fraction that represents how many fish are in the aquarium. Alright, that is more of an ACT question that we wanted to review with you and have you have some exposure to. And that's it. Alright, so kind of the last one's going to throw you for a loop. Alright, that's kind of an ACT question we wanted you to see. However, the simplifying rational expressions and included the excluded value, the x cannot equal this, or the x cannot equal that, or the y cannot equal that. Alright, that's fair game for your quiz, so make sure you're ready to go.